Hi, Chem 100, and you're in Lab 6. And now that you're feeling more comfortable with the long form of electron configurations, now I want to talk about how we can make those a little more simplified, because as you can probably tell with those bigger atoms, these electron configurations can get a little unwieldy because they're so long. And there's actually a shortcut that we're going to use. These shortened electron configurations are called abbreviated or condensed configurations. There's actually a lot of different names for this, but abbreviated is what the book calls it, and I tend to call it condensed. So we're going to do the first one in your lab in the second part together, which is silicon. So we're going to take a look at the periodic table, and we're going to find silicon. Now, silicon is right here on the periodic table, number 14, and here it is. So that is silicon. And so what we're going to do is we're going to write the electron configuration, but instead of using the Aufbau diagram like you saw in the first video, we're going to practice using our locations on the periodic table. Now to do that, I want to refresh your memory on the different blocks that exist in the periodic table. So if you recall, this blue section right here on the left, this is called the S block. And that is also joined by, at the far right, the helium. In the middle, we have the D block, and at the right, we have the P block. And what these blocks signify to us is the very last sublevel of the electron configuration, what type of sublevel it is on any element's periodic electron configuration. So which type of block it's in tells us what the last sublevel type is. And then bonus to that, we can tell which energy level that sublevel is by looking at the period number. So in period 1, that's occupied by the 1s, that's in the first energy level. All elements in the second period, they're filling up their second energy level. In the third period, they're filling up their third energy level. In the fourth period, they're filling up their fourth energy level, so on and so forth. The one exception to this is in the D block. As you may notice, in the fourth period, our D block is signifying the 3D sublevel. And that's because the 4s sublevel is actually lower in energy than the 3D. So atoms will start to fill up that next energy level before they get to their D sublevel. And then once the S is filled in the outer or valence energy level, they'll go in and start adding electrons to the D in the inner sublevel just below that. And then once the D sublevel is filled, they pop back out to fill out the valence energy level. So for example, if we look at the fourth energy level or the fourth period, we fill up the 4s, then we fill up the 3D before we go and we fill up the 4p. So we look at both the block as well as the period number to see what our last sublevel is. Now we can use our shortcut. So that was a brief overview on using the location on the periodic table. Now let's talk about how do we use a shortcut for making our electron configuration shorter. So I'm going to go back to our periodic table and going to go back and find our silicon. What we do is we can use a shortcut of a noble gas to signify the inner electrons, the non-valence electrons in an atom. And so to do that, we're going to be abbreviating with special numbers. So all of these numbers in group 18, these are the noble gas electron configurations, and these are the only shortcuts we can use. So for example, for silicon, we're going to use the noble gas that comes just before silicon. Now, silicon is number 14, and when we go and we look at our noble gases in group 18, The noble gas that comes before it, if we go all the way to the end of the group, that's not the one we're looking at because that argon has more electrons than silicon. So we're going to go up one to find neon. That is our noble gas that comes before silicon. And we're going to write neon's symbol with brackets around it. And what that's going to do is that's going to signify the first 10 electrons of our configuration. And so we don't have to write that whole configuration of neon. We just use its abbreviation. Now, how do I continue on from there? That's the tricky part. So once we have neon written, that's number 10, we're going to go to number 11. And we see that that's in the 1, 2, 3, third period. So our next energy level is the third energy level. This right here, this is in the S block. So we're going to be filling up our 3s sublevel next. And we're going to go in this manner until we hit silicon. So because silicon is number 14, all the way over on the right, that means that we're going to fill up that S. It is 2 elements wide for that block. The S block is 2 elements wide. So we can fit 2 electrons in that sublevel. So once we fill up the 3s sublevel, now we're going to go to our next element. Now there's nothing in the middle here, so we're going to hop on over to aluminum, which comes right before silicon. Aluminum is also in the third period in the P block, so that means we're going to be filling up the 3p sublevel. Now silicon is right in the middle of that block, which means we are not going to be filling up the 3p. We count from the start of the P block, which is right here, right before group 13, and we count over aluminum is 1, silicon is 2. So there are 2 electrons in the 3p sublevel. And this right here, this is our electron configuration, our shortened or condensed configuration for silicon. So now you're going to do this for several other elements, practicing writing the condensed configuration, which means for each one, you'll need to find the noble gas that comes immediately before. And we do that by going to the end of the row and go up 1. So go to the end of your period and up 1, and that's your noble gas starting point. All right, good luck. Let me know if you have any questions.